Me on the freeway. Anyway, okay. So 0 is greater than 25. False. Okay, so that means it's false here. So where do I shade? Inside. Yeah, yeah, yeah. I can't get anything by you. Okay, then I'm going to bring this guy down here for a minute um to work on before I graph it because I need to get it into slope intercept form. So minus 4x from both sides. Yep, exactly. Okay, so let's talk about how to graph y equals negative 4 over 5x. So intercept is 0, right? Okay, but wait, pause there. What is that going to mean for our test? Nice. I can't get anything by you guys. Trying, pulling out all of the tricks over here, and nothing's working. All right, so down 4 over 5. This one's going to be solid with my safe T ruler. What do you want to do? I was gonna say 1, 1 just because it's easier to see what side of the line it's on. And it doesn't really matter, but the important thing is plug it back in before you messed with it at all. So back to the original. Okay, now this one I did on purpose. Sean got a good night's sleep again and noticed that there's no double shaded region here. And I did this on purpose because I wanted to talk about it. When there's no double shaded region, no solution. So all these last two here, I tried to do a couple weird ones just so you wouldn't be thrown off. I know, man. Not not throwing you off at all. I'm trying really hard. Alas, you're thwarting all of my attempts. Thwarters. Anyway, so the warm-up should be done. I'll stamp those ASAP. Okay. Um, I don't think we're doing anything else in the packet other than stamping later. Oh, good. So I combined 85 and 86 into one problem so that it would look like note, but it's really, there's a B. Don't get excited, there's a B. But I wanted it to look like one thing so you could look back at this and put it on your note card if you wanted to. The first one we're gonna treat as an inverse style problem. And the second one, we're just gonna do our blue sheet. Oh, code. But there's census. Oh, we gotta go to student. It was not me. What?
Two problems at once.
Kinda. It's really two problems, though. It's just I made it an A and a B so that it would look like notes. I don't know. Now this problem right here, A is an inverse problem, so I'm gonna do my usual colors for that. Um, just so you know. Alrighty. So first thing I want to mention is that this is an exponential. Great, Mrs. Talbot. Okay, and um exponentials. Here, let me get my blue sheet. Exponentials, I want to start with the asymptote. So exponentials have a horizontal asymptote at y equals k. Yep. And they have a locator point of h comma k plus a. Okay. What is h in this problem? Negative one, comma, k plus a. And 0 plus 1 is 1. 3 to the 1 is 3. Minus 2 is, that doesn't make any sense. What did I do wrong? Oh, crap. No one noticed. No one noticed. No one noticed. I made a mistake. Made a mistake. Made a mistake. What's the mistake? There's no A value. This is the base. This is a 1. I'm gonna look really smart in sixth period though. Okay, 1 plus 1 is 2. 3 to the 2 is 9. Minus 2 is 7. Negative 2 plus 1 is negative 1. 3 to the negative 1 is 1/3. 1/3 minus 2 is negative 1 and 2/3. Please stop. Negative 3 plus 1 is negative 2. That's 1/9 minus 18 ninths is negative 17 ninths, which is negative 1 and 8 ninths. You could really just do that in decimals. It'd probably be easier, but anyway, okay. So now we're gonna graph that stuff in blue for me. Okay, and then the last thing I want to do, that's actually not true. The almost last thing I want to do in this problem is domain and range. So I'm going to go back to my blue sheets. This is the exponentials blue sheet page. The domain is all reals. And we have a positive a value in this one. A is 1. Y is greater than k. Y is greater than -2. Okay, not done yet though with the blue pen. Almost done with the blue pen. Okay, are there any questions about my just plain old graphing an exponential? I haven't really done the problem yet. It's just taking me a hot minute to do the problem because I'm refusing to use a graphing calculator table. If I had given in to graphing calculator table, this would have gone on much faster, but I'm not. Okay, anyway, this is actually an inverse problem. So I want to do the steps in blue and then I will be done with the blue pen. There's only 2 steps. That's false. There's 3 steps. Okay, so I plug a number in here. So as I was making the table, I always do the things where I cover it up. So what was the first thing that happened? Add 1. Okay. And then I did, it's called 3 to the power. So 3 to the power of whatever that was. And then I minus 2. Okay. All right. So now get out your inverse pen if you're a pen switcher like me. Right. Okay. So first step, add 2. What is the undoing of 3 to the power? Log base 3 minus 1. Okay, so I'm going to write it up here. Y inverse equals. So I want to start with x, but I notice I'm going to have to put log 3 in the front of that. So I'm going to put x way over here. And then plus 2 first. Log base 3 of everything. Minus 1 on everything. Okay, inverse table is easy. We just flip it. Looks pretty good. Pretty good. I'm kind of happy with it. Okay, and then symmetry. Mm-hmm, mm-hmm. A lot of stuff. And the only thing I think really that is new to you in any of this stuff is this right here, the 3 to the power and the log of base 3. I think that's the only new thing in this whole problem. So we just have to ingrain that into our routine. Okay. Any questions about A? Who needs more time to make their stuff all situated? Okay. Take your time. You guys can relax for a second. For goodness sakes. Okay, you guys, there's B. B is not nearly as much as A, but I would like you to get out your blue sheets after you set up B, please. And look at the logs that we did yesterday. I need to stamp it anyway, so if you could just leave that out, that'd be helpful. Okay, so on B, this is not an inverse problem. This is just literally a logarithm problem. And the directions are to graph it, but you need to also state the asymptote, the locator point, and the domain and range. So we're going to do it off of the blue sheets. So I'm going to look right here. There's my general equation. Starting with the asymptote. I always start with the asymptote. I think it's easier to visualize everything with the asymptote in there. It says vertical at x equals h. What is h in this problem? 1. Okay, so vertical asymptote x equals 1. Done. Okay, locator. H plus 1 comma k. Okay. H is 1. 1 plus 1 comma 2. Yep. Okay. Domain. X is greater than h. X is greater than 1. Range. All real numbers. All right. So we're going to start with the vertical asymptote of 1. Then we're going to graph the locator point of 2, 2. Okay, now this is how we're going to do this. And please listen carefully. You can graph this on the graphing calculator. I showed you how. I don't need you to be that scientific with it though. If it's got a positive A value, it's going to come from the bottom and go increasing. If it's got a negative A value, it's going to come from the top and go decreasing. I just need you to sketch it in. But remember what I said about the graphing calculator. It looks like it's going to stop. You need to make it go all the way through, all the way down if you do the graphing calculator. I figure it's easier to just not. Just kind of like rational function, just sketch in the general shape. That's it. That's it for that one. Yeah, not bad. Okay, we have one more problem today and then we're already done. I know. But I have a lot of things to stamp, it seems. I have a question. Did you guys do a homework problem about aliens? You would know. Was it about the number of fingers that aliens have? You would know. If you don't know, then it's a no. It's fine. It actually, there's a point to it. I'm not being like my usual goofy self. There's a actual homework problem that has to do with aliens. Hey, you guys, so we're gonna start with the actual formulas here. So this is your exponential. And this is where those letters go in the log. So there's your like temporary inverse and then to the logarithm. The really most important thing for me is that you guys understand that b is the base of the exponent and b is the base of the log. So if you can do that, then you're totally fine. All right, so first one is not equal to anything, so I'm going to make it equal to x. Giant and circle. 5 to the x equals 125. So follow it around. 5 to the x equals 125. Okay, 125 is 5 to the third. Yep. Okay, equals x. Giant and circle. 2 to the x equals 1/8. All right, so I'm going to do this one in 2 steps because I want you to see everything that I do. I can do it in 1 step, but I'm going to do it in 2 because I think it's a better idea. So the first thing I'm going to do is make this 2 to the x equals 1/2 to the third because 8 is 2 to the third. And then, yeah, I'm gonna bring it upstairs and say 2 to the x equals 2 to the -3. Okay, C already has an equation, so I don't need to put the equals x. The x is in a different spot. 2 to the 0 equals x. What's 2 to the 0? 1. Great job. Okay, now D. D is missing something. No base. Okay, so this is plain log. And what I want to show you is that there are buttons on your calculator for plain log. This is not what I'm going to use for this problem, but there is a plain log button right here. Yes, and I want you guys to look at the space above the log button and tell me from my calculator, what do you think the base is of regular log? 10. Can you tell that in the second spot, it's got the opposite, the undoing of it? 10 to the x. Okay, so just like when we write a square root, we don't write the little baby 2. Whenever there's a plain log, you guys are going to have to put a 10 in there. And the reason is literally because you have 10 fingers. So, quick note, the ancient Babylonians did not count in tenths. They counted in a hexadecimal system base 60. So which means that they had numbers for zero, all different numbers for 0 through 60. And then they would put the number in front, like we do for 11 or for 10. You know how we like take 0 and we're like, okay, that's one group. Their groups were groups of 60. They had all different characters, 60 different characters. Yeah, 60 different characters, including 0. 60 different characters for numbers. And then they would just put the number in the front after you got up past 60. We count in base 10 literally because we have 10 feet. That's the whole point. It was Muslim mathematicians that created our decimal base system with base 10. much easier than the ancient Babylonian system. But I think it's just super cool. It's not actually the first counting system. Okay, so equals x, you still need to put the equals x. Guidance circle 10 to the x equals 6. Now, there's no way for you guys to solve this yet except for guess and check. So take your calculator out. Give me a guess.
0.77.
No, not you, someone else. Like 10 to the 1 is too high.
20.
Closer.
Oh,
Wait, we should try 6, 7 first. Too low. Not quite there.
oh, 3.5.
Nice. Okay, so which you could also get by just doing log 6 on the calculator. Okay, however, the reason I did all of this is because of the directions. The directions, the notes were not evaluating logs. What were the notes? Yeah, the notes were logged exponential form. So if the directions say rewrite an exponential form, you can't just type log 6 in your calculator. You have to rewrite it 10 to the x equals 6. That's you'll miss a point if you don't rewrite it to exponential and it says rewrite it to exponential. So that's why I did all of that extra stuff. But before we move on. Okay. One second. Just a quick fun note. This is Babylonian calculations. Yeah. This is 16 math problems. It's not. I think it's cool. I had to take history of mathematics class to become a math teacher. There was a page in here with the characters on it. Oh, hold on, it's right here. Just a sec. So, oh goodness. So here's some. Yeah. Here's some. I find them pretty cool. Literally, look at the homework problem. Like, express each of the given numbers in Egyptian hieroglyphics. Like, how cool is that?
You solved it?
Got nothing. Forgot it all. Oh yeah. Yeah, I had to take that class. Anyway,